today's objective, slope and rate of change. Let's go over some definitions first. Rate of change, the relationship between two quantities that are changing. If one quantity depends on the other, then the following is true. That means that the rate of change is equal to this particular relationship. The change in the dependent over the change in the independent. Number 2, slope. A number that describes the steepness of a line. Slope is a rate of change. Okay, so when we're talking about slope, we're always talking about the vertical change to the horizontal change. And let's talk about that in the variable terms. M is what we're going to use for slope, and Y is going to be representing our vertical change, and our X is going to represent our horizontal change. When I mean Y, your Y coordinates, your X coordinates. Okay. Vic number 1. If you have the graph of a line and want to know the slope, we're going to use, when we have a graph, rise to run, rise over run. So here's our graph, here's our line, we have 2 points, and we're going to talk about rise. Remember, rise in our numerator is going to be our Y value. So how many units am I rising up? Well, if I count them, here is 1 unit, here is 2 units. So I'm going up 2 units. So when I go up 2, and then from this point, I go up 2, and how many am I going to the right? Well, I'm going 5. So my rise, by going up, is a positive direction. So that means I'm going 2 units. In my denominator, remember, we're talking about the X value. That is my horizontal change. And so that means going right, I went a positive direction. So the value of that is going to be a positive 5. So overall, with that relationship of slope, rise to run, the slope is 2/5. Okay? Example number 2. Again, here's my 2 points. Okay? So from this point to this point, when I rise, I go up 3 units. Okay? I'm just talking about from here, 1, 2, 3. From this point up, that's 3 units. Then going over to this point, that gives me 5 units. But notice the direction. I went up, which that direction is positive. Okay, so they gave me positive 3. I went left 5. Notice the left is a negative direction. So my slope, rise to run, positive 3 over negative 5, which is negative 3/5. And I can tell it is definitely a negative slope as it slopes downward. All right. Finding slope given 2 coordinate points. Okay. So now we're going to talk about the algebraic formula for finding slope. Notice I have all this notation here. Notice I have y with a subscript 2 minus y with a subscript 1 all over x with a subscript of 2 minus x with a subscript of 1. Now, by default, I have that subtraction. So subtraction is what's going to be in the middle as far as of those 2 coordinates. And notice I have y2 minus y1. That means when we're talking about 2 points, I'm taking my y values and I'm subtracting them. But the thing is that notice we're going from one point to the other. So which x value belongs with this y coordinate? Well, x2. So I need to make sure I'm going from that point to the other point. So when I'm plugging it in, I need to make sure that's what I'm doing. All right? And we're going to practice that. So Vic number 2, the x coordinate you use first in the denominator must belong to the same ordered pair as the y coordinate you use first in the numerator, which is what I just said. Okay? So examples, let's find the slope. Here's my 2 points. Okay? By default, you can see that I have subtraction right here. Okay, here's my ordered pairs. My y's, so 7 minus 1. Here's my x's, and notice that with this 7, the x belongs to that one is the 5. So notice that one came first. That's Vic number 2. So when I subtract here, what's 7 minus 1 is 6. Here, I have subtraction, but I have a negative. So add opposite. That gives me 5 plus a positive 2 now, which is positive 6/7. Okay? So here, my y value is -1 and -6. So -1 minus -6. When I add its opposite, I have a +6 now and a -1. So when I subtract those, I get a +5. Now I have to make sure that when I put the -1 y value, or the x value that belongs to that, is 0. So I have to take that x coordinate first. So 0 minus 1 gives me a -1. So the slope of that is -5. All right. So horizontal and vertical lines. Okay. Let's find the slope of each of these lines. So I gave you a line. Here's your 2 coordinates on that line. So let's plug those into the formula. So notice that the y values are both 2. So I'll plug those in. The x values, 1 minus 4. So when I plug those in, as you notice, I have 0. Because remember, we had our relationship is rise over run. Now notice in this graph, is this graph rising? Is it going up or is it going down? No. So it makes sense with a value for the rise is 0. And when we do the mathematical calculations, it is 0. Now let's look at the run, that horizontal change. When I subtract, I do get a value that's -3. But remember, 0 divided by -3 is 0. Here's very important. The slope of a horizontal line is always 0. Because in other words, it's not rising, it's not going up, it's going down. All right, let's look at this vertical line. Same thing. Remember the rise to the run. So where rise is always our y coordinates, okay, our vertical change. So when I plug in my y's, which is 2 and a -1, here remember, add opposite, you get a +3. Now my 4's for my x coordinates are the same. So I get a 0 in the denominator. Remember, we know that we cannot divide by 0, which means that the slope does not exist. It is undefined. So the slope for a vertical line is always undefined. And remember, if I apply the vertical line test, we already know that it does not exist because it's also not a function. All right, summary of lines. Slopes of lines, sorry. So let's look at this one. I can tell that from this particular graph, a line with a positive slope slants upward from left to right. So it slants upward. In other words, a positive slope, when I have that rise to run, the value is going to be positive. Now I could have a negative divided by negative, that still gives me positive. So in the end, once I simplify, it's going to be a positive value. And I can read it from left to right. As it goes up, it is definitely positive. Let's go to this one. A line with a negative slope slants downward from left to right. So from left to right, it is definitely going downward. So that means if it has, when I'm talking about the rise to run, whenever it equals, remember I'm going to have a negative outcome. Remember, a negative divided by a positive is still negative, or a positive divided by a negative is still negative. So I get that same outcome when I'm talking about either algebraically or graphically. Okay, there's that same correlation. So here, a horizontal line, we just talked about that, has a slope of 0. Okay, so I know that there is no rise. Okay, there's definitely no rise. And I'm going to have some value for the run. But again, 0 divided by whatever number is going to still give me 0. So the slope is always 0. Vertical line, it has a slope that is undefined. And we also know, because if it doesn't exist, it's not even a function. All right, it is a line. It is an equation of a line. However, when we define that slope, there is no value. Okay, it's not even 0. It does not exist. It's undefined.